We're going to start out with doing kind of a deep dive on lines. So this shouldn't be like gargantuanly new. You shall have seen this for a long time now. So what we have here is I have 3 different ways of representing some data. I have an equation or a story problem for Isabella's bill. I have a table with her past few months' bills, and I have a graph with what she's paid on her bill. And what I want you to do is I want you to find the rate of change. And there are lots of different ways to do this. I want you to find the rate of change. What's another word for rate of change? Slope. So see what you can do. See if you can find that slope. There's many, many different ways to approach it, and we're going to find all the different approaches. Once you find it, see if you can write an equation for how much her bill costs. And you can work with your neighbor too if you want to. Like, totally fine. When I find stuff that I drop. Show my phone. All right. What is one way to find that rate of change? Oh, yep. So if you're looking at our table, we're looking for the change in the Y over the change in the X. That is a really, tricksy way to write something. We don't like to have words out all the time. Math class, not English. So there is a shortcut notation. If you've taken physics, you've seen it. But it's a delta is what it's called. Delta Y over delta X. This is a symbol. It's a Greek letter, technically. It means change in. That's all it's used for. So it's a fancy schmancy way of doing it. It looks like a little triangle. Another way, remember how to do that? Has a couple of R's in it. What do we say? What over what? Rise over run. These are all ways to do that. And so we can look in our table to find out how that happens. Looking at, and we have this picture here telling us that kilowatts is our X, because that's what it's labeled out here, or kilowatt hours. iPad, can you stop losing your mind, please? Thank you. All better. So that label is on our X's. This tells us that this is our X. Oh, you cannot see that teal up there. Let's try that with black. Much better. And this is labeled on the top, so this is our Y. So if we're looking for the change in the y's, we look at how it's going from here to here. How much did it change? 15. What is the change in our x's? 100. Over here, changed by 100 on that same segment. So we can find our slope here by 15 over 100, which we could simplify. To get it as a simplified fraction, what's it going to be? Not 1/5. 15 divided by 4 is not 25.
Oh, 3 over 25.
Thank you. 3 over what? Because we're dividing both by,
20.
we're dividing both of these by 5, right? So we can simplify this down to be 3 over 20, which is great, but what is the actual rate as like a cent, money? How do we get that as a decimal? 3 divided by 20. Also known as 0.15 dollars. So when you're looking at a table, we can use the change in y over the change in x. This is the most accurate. My iPad is in a mood today. That says accurate, not accuvate. I promise. It's an R. There we go. Most accurate. Okay? Using the table is your most accurate way. Our laziest way is to look in our sentence. And if we're super duper lucky, we will only see the keyword once. What is the keyword that tells us we're looking at slope in this one? Per. Yeah, that per. Only problem is here we got 2 of them. So per means that's what we pay attention to, and we're going to have to think really carefully. Since we're doing per kilowatt hour, that means that this guy is our slope. Our bill that we're looking at here is a monthly bill, so this per month is irrelevant. That's for everything we're looking at here. Okay, since we're looking at a monthly bill, it doesn't matter that it's every month, it's every bill. So sometimes they will try and trick us with that keyword. So per is our laziest way, but it's easy to get tricked. And our laziest way to find it, that is simply counting, is to look at our picture, find 2 points that are on pretty tidy dots, and straight up count the boxes. This goes up, rise, and it's counting by tens. So 10, 20, 30. So this one has a rise of about 30 and a run of counting by 100s, 100, 200. So we have 30 over 200. We can come over here, we can simplify this, both divide by 10, so we get 3 over 20. Oh look, we wound up with exactly the same slope as before. Counting on the graph is good and gets us close. If all we need is an estimate, counting on the graph is fine. However, we can't always tell, especially when our scale is counting by 100s or 10s. What if that was 199 instead of 200? It would be almost impossible to tell on that scale. Or what if it was 51 instead of 50? Or 9 instead of 10? So it's really hard to tell and be super accurate, so counting on the graph gets us real close. But if we have numbers, it's a much better option. Okay? So You guys, whatever you find helpful is what you put in the lines below. I'm not going to tell you strictly word for word what to put in there. I like having all of my different options here for the change in y, change in x, delta y, delta x, rise over run. Your book, your choice, your paper. Okay, looking for that word per is going to be our key when we're looking in paragraphs for a slope. But that's what we're looking at there. So we found 3 different ways to find our slope up here. Because we've done that before. Should be hopefully familiar. But then what we're going to do is we're going to talk about what it means for slope. What slope means. So the next page is where we're going to talk about that. It should be page 5. And I want you to talk to somebody near you. We've got the cost of peaches. We've got the cost of plums. Which one costs more per pound? And I'm going to close the door because we're going to have a little rowdy in the hall. You can talk to a neighbor. See if you agree. Alright, even with no numbers anywhere on this picture, which one costs more per pound? Peaches. How do we know? It's steeper. Good word. Like it. Peaches. Because steeper. Steeper meaning higher slope. Its rise is going faster than its run. Or at least its rise is going faster than plums. It's increasing more quickly. There's an infinite number of ways to word it. As long as what you say is clear, I do not care which words we use. Okay? So if bananas cost less per pound than peaches or plums, exhibit is on my next page. Haha. Bananas cost less per pound than peaches or plums. Draw bananas. Not a banana. Draw bananas as a line. Just clarify. Draw on a line that might be for bananas. And you can just draw it onto that same graph that you have there up underneath the peaches and plums. All right. In what section do you have your bananas? The yellow, the green, or the purple? Purple. When in doubt, give yourself a choice. So like maybe it's ooh, wrong pen. So maybe this is 2 pounds. Peaches cost the most, plums cost less, bananas are even less than that. So we can see where that is. I would put bananas somewhere down here. B-A-N-A-N-A-S. I cannot spell bananas without thinking about that. No doubt. Okay, So it's all about the relationship between them. We're not concerned with numbers. There is not a single number on this page. It's all about the relationship with them. Okay? So thinking about that, we're going to start thinking about variables and labeling variables and all that kind of stuff. So I'm going to ask you a question that's going to kind of lead into what we're doing tomorrow. What is our independent variable? The number of pounds. That is the piece that we change. I get to choose if I'm going to buy 1 pound of bananas or 50 pounds of bananas, because, I don't know, I'm making a giant banana castle. Or 27 pounds of bananas, whatever. I get to choose that. I don't get to change the cost. The cost is our dependent variable that is changed because I changed my mind. So that's what I would put in that little space below too. Is that our independent variable, and I would write independent is the number of pounds. It's what, ooh, that green is not going to show up well. I need a different color that's also dark. It's what we can control. What we control. Or what the user controls, or what our mystery person controls. Bless you. Our dependent variable here is our cost. It's the response, like our cause and effect. So this, I'm going to put effect for cause and effect. So it's what is changed because of what we chose. It's what we control or what we choose. Whenever we're working with independent and dependent variables, our independent variable, if there is a unit of time, is going to be time. Because we can choose what time we stay there or how much time we use. I cannot make time go backwards because I decided to buy a different number of bananas. I don't get to make time change. I can choose a different amount of time to do, but I can't make time go backwards because I bought fewer bananas. Be cool if I could. But we can't. Okay, and we'll talk more about independent and dependent variables tomorrow. On the next page, there's a whole lot of practice with that because we're going to work with that a bunch. But like I said, this class has a whole lot of good time for you guys to like do homework and stuff and catch up on things and do what we need to do because I'm actually done. Yes, dear. This one? Gotcha. Okay. So you guys have a lot of time. The first homework for this chapter is not up yet. It'll be what we talk about on Friday. Will lead into homework 1. Okay? So, yeah. Pretty chill. Yes, dear. Yes, dear. All right, pass. Okay, pretty chill. Ooh.
You know what I mean? For today, she said.
You're welcome. Yes, dear.